Hey, it's Mr. Cohen, and we're back for some geometry. Today we're going to talk about triangles in different ways. The first way, and this comes up in the book around pages 378 and 379, is something we've already talked about. It's an idea of triangle inequalities that the longest side is across from the biggest angle, the shortest side is across from the smallest angle, the medium side is across from the middle-sized angle, and vice versa. We don't really need to discuss that any more than we already have. That's on pages 378 and 379. After that, on page around 386, we get an idea called indirect proofs. And here's how an indirect proof works. We're going to take the opposite of what we are trying to prove and prove that it is false. As an example, suppose we had the problem x plus y, this is an algebraic version of it, but suppose we had the problem x plus y is greater than 60, and we were trying to prove that either x is greater than or equal to 30, or y is greater than or equal to 30. Well, to prove it, we would assume that x is less than or equal to 30, and that y is less than or equal to 30. Well, if we picked 30 even for x and 30 for y, we would get something that is less than 60. We're trying to prove that it's greater than 60, so this proves that it's wrong. So when you're doing an indirect proof, you are trying to disprove the opposite. It's something that you probably use in arguments more and more than you use in math. In fact, I remember, disproving something to my father when I was your age, but I'm not going to go into that. Okay, the next idea, and again, this is actually hopefully a quicker video, is a different idea of triangle inequality that we've also talked about, that any two sides, the lengths of any two sides have to be greater than the third side. So if we have sides that are 4 and 8, the third side could be, has to be less than 12. The third side has to be greater than 4. And what we would end up with is that 4 is less than x, which is less than 12 for the third side. You will see problems like this, numbers 25 to 30, on page 398. The last thing we're going to talk about in this video is an idea that should make, hopefully, pretty good sense to everybody, too. We've got two triangles. And let's say that this side is 12 units and this side is 10 units, and whether they look like that or not isn't really important. This is called the Hinge Theorem. And the Hinge Theorem, if you think about a hinge, if you think about sides that are closer or further apart from each other, well, let's say that this angle was 50 degrees and this angle was 40 degrees. That's the included angle. The Hinge Theorem requires that you're talking about the included angle. It requires that you have two sides that are congruent. Well, all the Hinge Theorem, let's call this x and let's call this y. All the Hinge Theorem says is that if this angle is greater than this angle, that x has to be longer than y. And the converse of the Hinge Theorem says that if y is greater than x in the same diagram, that this angle would have to be a greater measure than this angle. That's really all there is to it. It's a pretty basic idea. The problems for the Hinge Theorem start in the book on page 405 and go all the way to page 409. There are good problems like this, not great problems, but it's pretty self-explanatory, I hope. That's all for now. We're going to be working on getting some direct online learning soon. I want to thank my wife for videotaping this. Here's Rocco. Thank him for not barking. BB over there not barking. And as always, if you have questions, you can email me, mcohen2@pghschools.org. Stay safe, stay healthy, and stay sane. Take care.